Design Unit 4 Symbol Table Error Detection and Recovery. This is the fifth number topic, that is lecture number 6 of 6. And here we will discuss about the concept of error detection and error recovery. So in the phase of compilation, all possible errors made by the user are detected and reported to the user in form of error message. This process of locating errors and reporting it to the user is called error handling process. Functions of error handlers are detecting the error, reporting the error, recovery of error. Classification of errors. So errors can be either compile time or it can be run time. So compile time can be lexical phase error, or it can be syntactic phase error, or it can be semantic errors. A parser should be able to detect and report any error in the program. It is expected that when an error is encountered, the parser should be able to handle it and carry on the parsing the rest of the input. Mostly it is expected from the parser to check for error, but errors may be encountered at the various stages in compilation process. A program may have the following kinds of error in various stages. First, it can be lexical error. Lexical error means name of identifier typed incorrectly, like that. Syntactical error means missing semicolon or unbalanced parenthesis. Semantical error means it can be incompatible value assignment. Logical error means it may be code not reachable, infinite loop, etc. There are four common error recovery strategies that can be implemented in the parser to deal with error in code. First, it can be error recovery strategy can be panic mode. So what happens in panic code? When a parser encounters an error anywhere in the statement, it ignores the rest of the statement by not processing in out from the erroneous input to delimiter such as semicolon. This is the easiest way of error recovery, and also it prevents the parser from developing infinite loop. Statement mode. Second can be the strategy can be the statement mode. When a parser encounters an error, it tries to make corrective measures so that the rest inputs of a statement allow the parser to parse ahead. For example, inserting a semicolon, replacing comma with semicolon, etc. Parser designer have to be careful here because one wrong correction may lead to an infinite loop. Third strategy can be the error production. What happens in this case? Some common errors are known to the compiler designer that may occur in the code. In addition to designer, uh, the designer can create augmented grammar to be used as production that generate the erroneous construct when these errors are encountered. Third strategy can be the global correction. The parser considers program in hand as a whole and tries to figure out what the program is intended to do and tries to find a closest match for it, which is the error free. When the erroneous input for a statement X is fed, it creates a parse tree from closest error free statement Y. This may allow parser to make minimal change in source code, but due to the complexity, time and space complexity of this strategy, it has not been implemented in practice yet.